problem here, no? So, yun yung matigdan, no? Nagsugod tag mga kuan lang, mga values lang, M, K, L, etc. And then, from basic, and then hinayin na naka-apply tag mass. And then, we have the actual stiffness, na-apply na to bending stiffness, and then eventually we arrive with torsional stiffness, no? So here, our problem here, we have a diving board. So we have a diving board here. So diving board, bakanan gani sa kanang mo dive sa kanang maglangoy. So that is a diving board. For divers, a certain level of static deflection is desirable. So we have a deflection here, no, represented by delta. So yun nga nga ang diver na certain static deflection nga desirable. So unsa man ning mg? This is the weight of the diver. Compute a design formula for the dimensions base, height, and length in terms of the static deflection, the average diver's mass, and the modulus of the board's material. So this is the section of the board, base times height, and then it's inertia, moment of inertia is equal to bh cube over 12 because this is a rectangle. So yun yung magbuhat ako ng equation nga ang base, height, and length is in terms of static deflection, katong delta, and then the average diver's mass, of course, mass M, and the modulus of the board material, E. So we have a force here, panaog this is an example of lateral, or the bending or transverse stiffness. So ato ang actually general equation for the bending stiffness is EI over L cube. Pero, dili na siya na to gamiton here. Actually, the deflection, so actually, if you remember in your lower years, if we have a beam, and then we have an applied force P here, diba, it will have a deflection. And then that deflection is equal to itong ipakita na ko sa inyo sa first page on the introduction. This one, no? We have PL cube over 3AI. And eventually, ang imong masolve din na ng stiffness K is equal to 3EI over L cube. So we just came back here, no? This is PL cube over 3EI. And eventually, we have our stiffness K is equal to 3EI over L cube. So we have our L, we have our E, and then our I. So ito lang na substitute. Our K is equal to 3E times our I, which is equal to BH cube over 12 over L cube. So we have E BH cube over 4 L cube. Next, sa may ma-relationship na to ani nila. So we have a diver here, no, with a force P, and we know that by Hooke's law, F is equal to the stiffness times the deflection. Sige, pakitan mo tag in terms of deflection po daw. So we have the deflection is equal to F over K, and then the force acting here is the weight. That's why we have the mass times the gravitational acceleration over K. So we just substitute, no, value sa K. We have the mg over EBH cube over 4L cube. Numerator times the reciprocal of the denominator, we have mg, or mass, times the gravitational acceleration times 4L cube over EBH cube. Na ingon man niya nga ang BHL daw, ang base, height, and length should be in terms of deflection, mass, and modulus. So dapat on the left side we have our this one, the base, the height, and the length. So we'll have this equation. cube over L cube is equal to 4mg over E delta. Or pwede po that the L cube over BH cube is equal to the modulus of elasticity times the displacement over 4 times the mass times gravitational acceleration. Either they are correct. So this is the formula of the base height and the length in terms of the mass, the elasticity, and the deflection.